Hello YouTube and welcome to yet another web app tutorial, episode 4. And in this tutorial we are continuing on from our last episode where we created the user router to go alongside our ping router on our server. And now we want to get to a stage of having to create the client, which will be our acts as our intermediary, our connection to the server. So we'd put that in our browser-based web app, or we will put that in the maybe a command line client as well. So we'll connect that up, and then we'll also create a couple of tests where we'll start doing some unit testing on our server. Again, a bit more demonstration purposes. We won't go to a full extent of all the testing that you might want to do, but it's enough to get the premise over. And then maybe in the next episode after that, we might revisit the middleware section. I've been designing this tutorial series for a colleague, and he's been enjoying it so far. It's just double checking, how those middlewares work, and maybe just go through that in a bit more slower, a bit more detail. And having done a couple more apps with this stack, I've seen a couple of little nuances in how to set them up and how to run them so it runs nice and efficiently. So we'll cover that in that next episode. First of all, let's go on and continue on with creating our next package, the client. So as we started with server, we have a pm workspace, and in that we declared that we've got the package called server. In here, we want to now declare a new package called client. So now pm will be aware just by adding that into the YAML file that we're going to be creating this client package, and that is going to map to our client folder. So we're going to create a folder called client, and so I've got my reference here. And as we before, if we cd into that client folder there on a command line and just do pm init, we can create our package.json for that. So it's like you say, it's a new package. It's automatically called it client. And in here again, as before, we type it as a module. Just like that. We will also just put the schema in there, again, just for good practice to help us do some continually type check our code. So the schema, of course, is the package schema. And that's really that's all really that's much is into it. It's the only other thing is now, because we're going to be using all like native Node.js or browser-based packages, and the main thing is going to be using this command called fetch, which actually goes and fetches data from a HTTP endpoint. So like, for example, our server REST API. So it's all going to be native packages. There's nothing really to install. The only thing we want to do is actually have a dependency with our backend. So pull in the types that we have for our endpoints, so we can then reuse the typing, make sure that everything through our set of modules are using the same types, and helps us hopefully minimize the number of errors as we code away. To do this, we'll manually add here a dev dependency, because we don't need the backend to run the client. We're just going to, like I said, export the types from there. And what we can do, because it's within our workspace, we're going to declare a package called backend. Server. This is server for here, and we're going to call it workspace colon star, and that's just going to tell pm to look for the server package within our own workspace, so you don't have to go out to GitHub or go to npm to pull a dependency in. If we just do npm install, let's do npm install, let's first -f client install, so we are working within that workspace. So filter on the client, it is now just resolving that packages, and it hasn't added any because of course it's just going to be referencing one that's already in our workspace. So now we have a node modules here. It's appeared, and it's actually referenced our server. There we go. It's just done a kind of a sym link, so it's kind of doing a reference to this package here. And as we update server live, it'll update the package in there as well, so we can code without having to continually update or reinstall packages. So in the client, we're going to create our index.ts, which is going to be our entry point. And we are, just before we're in our package.json, we'll just make sure that that's TS as well. So it all marries up. And in here, we're going to define our client. So what we want to do is going to export a class called client. And it's going to take a couple of fields. I'm going to say they're public, so people can access them and use them. It's going to have the endpoint, where you're going to, where is our server actually hosted? What's the IP address of that server? We're going to have a variable called token, which is going to hold our bearer token. Oops, I can spell today. There we go. And we're going to then have we're going to create here now a oh no, we won't do those just yet. I was going to say create the user endpoints and stuff, but we'll do that in the next tutorial. We'll just do the ping one for now. What we need to do is then create the constructor, which is actually going to instantiate the client. And we do like new client. We're just going to say this endpoint equals. I can just make it empty, so they can then someone can then define it later on. Just have that empty for now, and that is looking all good. And we are now going to create a function wrapper around this inbuilt fetch command that's going to do our HTTP requests, and it's going to add some nice neat like convenience functionality to our client that maps to how we're structuring our data. So we're going to call this public, so people can use it outside, underscore fetch. So the underscores you typically use to say, like you say, it's meant to be used as an internal function. You can always call upon it if necessary, but just a little indicator that it's not necessarily a function that you want to rely upon. And let's define that fetch function. So that fetch function is going to be an async function underscore fetch. It's going to accept a type. So what we're going to give it is to say when we start to build out our different calls in our client, we're going to give it the type, the response type that we expect from the endpoint. And we just go to this client. So what we're saying is that it's going to be attached to a class called client, so it needs to be aware of its own self, and we're going to just declare that for it. We're going to have a variable called method, and this is to define whether it's going to be a get, a post, a put or patch type request. We're going to have a URL, and that's going to accept a string, and then we're going to accept a params variable, and that is just going to be a generic key as a string, and it's going to be undefined, and we're going to default it as undefined. So that's going to be just the, as we like you say, login arguments or the register arguments for our endpoints. That's going to go in that params call there. Oh, just need to finish this one off. So it's a key string, and it's going to return any. But it could be a number, it could be a date. There we go. And now we want to complete that. There we go. So complete the function. It will help clean our log file issues up, and it's still going to declare some of the methods are not being called upon yet. Well, our variables, sorry. And now we're going to just log Again, this is just for, like, say, for our demo purposes. You'd have these as hidden in the debug configs. Normally, we're just going to have this as this.endpoint slash API, because we're going to be calling that API all the time, and we're going to add slash URL. So what this is saying is just going to print out every time a client's going to be making a request, when it does this fetch command, or what endpoint is it pinging. We're going to create a config, and it's going to be of type any for now. And this config is going to be configuring the fetch commands that we'll see in a moment. We're going to pass the method. Is it a get, post, put, patch method? We're going to set the mode to pause, and oops, there we go. And that's to say if it's allowed for cross-origin resource allocation. So imagine you're hosting the client on one server and hosting the back-end server somewhere else. Cause enables you to, get requests from different endpoints there. And then we're going to declare some empty headers. Okay, so what we're going to do now is just check the content of our incoming parameters. So params, we're going to say, is it of type object? If it's not undefined. And if so, of course, we're going to update our headers. And we're going to say content type equals application / JSON. So we're telling, and this is going to be sending to the server. We're going to say, oh, we're giving you a application.json body content. And now we're going to then define the body as JSON dot stringify our params. So that's going to make it into a nice string that's going to be attached to the body of our request. We'll then check if the client, this token has .length, let's say it's greater than 0, then we might have a bearer token, so someone's attached a token, and so we're going to pass that. We're going to put that into our headers. If you remember back, we had it as the authorization header. And we're going to call it bearer, so you're bearing this token, and we're going to apply this token. So now we've got a token attached to our request. We've got the parameters attached to our request. Ooh, we've got a missing brace there, parentheses. And now actually we want to create the request, the package that we're going to send to the server. So we're going to call that the request, and it's going to be new request, and it's going to attach. So we're going to, it needs the URL that it wants to go to. So we're going to go this.endpoint / API, because all our endpoints are going to be behind the API / API, and then we're going to pass it the URL. So that's the end of the endpoint, as it were, and we're going to pass it the config, so the details of our request, and then we're going to actually perform the request. So we're going to create, the R will be the response. We can actually call it response to make it nice and clear. So we've got the request, and now we're going to get the response from the server. So we're going to use the rate fetch. So that's the fetch command that I've been mentioning, and we're going to give it the request. So it's going to perform that. And what we're going to do is actually going to retype the request that's going to be returned, so it lines up with what we know to expect from our server endpoint. So what we're going to do is create a new file called, oops, not new folder, new file, types.ts, and we're going to, let's say, export a new type which is going to augment the existing response type that's in TypeScript in Node.js. We're going to call it HTTP response. It's going to accept T, and that's going to be a type that we're going to pass through to say this is the response that we'd expect to come from that endpoint. And we're going to have a few variations. The first one is when. So we can. This is kind of an if-else statement. So when the OK is true, so it's returned OK. The status is 200. Then we'll also expect the content that we're going to receive to be of type T, and it's also going to have all the extra keys and functionality of the standard response. We can then do that again. So if I just copy paste those elements, and in some of my fonts we've had it for 204, and again we need the and response. So again we're kind of adding to the existing response type. And then the last one we're going to do is going to find if OK is false, so we've got an error, then the content we're going to claim is undefined. Oh, 24, we're going to say it's undefined. So 204, we expect that we're not going to return anything. And the same with undefined here. Actually, if OK is false and status, let's say, is 400, because we've been using 400, we're going to say that status is going to be type because it's going to potentially bring back an error and data, some messaging for us to use. And then that should be okay. So those are some typings for us. If we go back to our index.ts where we've created this fetch function, we now want to say it's as, we're going to redefine it as a HTTP response from our types, and we're going to give it the T from the very top of this function here. So we're going, when we call it, we're going to say, it's going to have this type of response, and we're just redeclaring it here. So we know that when we get this fetch request back, it's going to be this response potentially with this content in it if it's been successful. So what we can do now is go to our response content, because we've defined, even though it doesn't necessarily exist in the normal response, we're going to add a key called content, which is going to be undefined initially. And then we're going to now check, we're going to say whether the, let's say we're going to do 200 and 400, the ones that we're interested in. Any of those includes is in the r.status. So basically we can say, not r, so I'm using my reference here. So response.status, I'm going to say if it's 200 or 400, then it most likely has some content in our JSON format. So if I then do content type, what we're going to look for is just double check the headers of the response as well. So we're going to get those headers, headers.get, and we're going to call it content type. Oh, missed out on something on my typings there. Oh, yep. Just need to add on to this one, and response. There we go. There we go. That's it. Let's fix that up. So we're going to get that content type if content type. So first of all, check if it exists, and if then content type, and the content type is or includes, we're going to say application/JSON. So just double checking that the content that is returning is a JSON format. If so, we're going to then unpack that content. So we're going to wait for the JSON to unpack itself. Response.json, and we're going to then have one more convenience function we're going to add, which will be, I'll just comment it out for a second, we're going to turn string dates into date objects. So we'll put that in there in a second, but ultimately once we've processed that, we're going to put the content as the content there. So we're going to receive that content as our response. So, and then all that is good. We now want to return response. Okay, so I just put in that comment there. We want to create a little convenience function. As you stringify the parameters to be sent over the web, date objects will be then returned as strings. So it's quite nice just to automatically process that object, and any dates that we identify, turn them back into date objects, so we can do some date manipulations further down the line. To do that, I've got a nice convenience function. I will just copy and paste this for, again, expediency. So yeah, please see the Git repo to see the details, but I will quickly connect it up. What it really does is recursively go through the object, looking at all the keys, checking using this regular expression, is it of type of a potential date type? If so, replace that value with the date version. So here it is, it says if it's of type string, and if we've tested it against our regular expression as if it's a date type, then we will then transform that value into a date. And then if it's any other type of object like a list or an array, perform that. So it's a recursive operation, so it continues down the object tree and then returns the, oh, it doesn't return, it just modifies that, and then we can pass it through to our response content. So that's the kind of convenience functions then to perform the fetch. Now we want to be able to do a call upon one of our endpoints. And the first one we're going to do is our ping one. So we're going to create a public facing function called ping, so someone can actually ping our server. And we're going to have a constant URL, and we're going to say, of course, this is at the /ping endpoint. And this is where those convenience functions really come into play. Is now I can just go response fetch, and we're going to expect it to return. I will get that a type in a minute. Let's call it any for now. And we're going to say it's a get request to that URL. So we will now want to be able to type that as what we expect our ping result to be like. So if we go back to our server and our, there's our here we go, types. So if we look at our types, we remember we've got our response.body. So we know it's going to be of this kind of type of a response body. Actually, we know that the data is going to be a string in that data object here. So what we could do is even update this to say, okay, the response body it's going to be of this type, and it's going to be, we're going to just default to any in here, and we're going to keep that as T there. So we can now define that response body anytime we'd like. Those are all exported from backend types. So if I remember my imports correctly, let's see if we can do this. So response body, there we go. It's already identified it with us, but it's done it as a relative reference. We should be able to do it from a global reference. it's installed the package correctly. Let's see if I can just do from the index. I might need to export those from the index. Double check that. So I can also export all our types. There we go. And just double check it's gonna. There we go, response.body from types. Because our entry point is index.ts, it's looking for that. So it's easier just to then export the types that we're interested in. We may not necessarily in the real world export all the types as a default there. That's what the star does. We just export what we need. So here we've exported the response body. We go, you're going to get this response body back. And we know then we can do another set of arrows to then say, okay, in that we expect it to be a string because it's going to be Pong. Hopefully that's it in that data object. And that's it. So that's us just now being able to create calls to our server, and we'll see for the user endpoint going forward and the to-do one, it's going to be very similar format, repeating this again and again, featuring different parameters and typing different responses. So when we start using the client in our web app, it's going to be able to tell us what the data objects that are expected from our server. So that's all installed, all created. Next stage is that's trying to create some tests that will use that. So maybe let's use it in anger and might as well use it for our server tests. So first thing we want to do is in our dev dependencies, we will then put client. This is in the server folder. In our client, we're going to say, oops, as before, workspace star. So it's going to look for the client within our workspace. By cd up. Let's just do f client, but this time f server install, just to give pnpm time to update itself and know that we've added that one manually. So now it should expect client to exist. And what we're going to use for our testing framework is just the inbuilt one, recently built in test framework for Node.js. And I'm going to create a new folder called _tests. And the first file we're going to create is something called, I'm going to call it test runner. Now what I'm going to do is going to be creating a instance of the server and then perform the tests. So I'm going to have basically two processes running, one to spawn a instance of the server and shut it down, and then one to run the tests. So in here we're going to use a inbuilt command called spawn. We're going to also import our init server from our index.js. Did we call it server? Oh yeah, yep. Just double check we haven't exported it, that's why. So let's export that now. Okay, so it says we've exported init server. So this top level, this script here is going to initialize our server, and then we're going to spawn our test run. So we're going to go pnpm, and best probably just do, because we're going to be in this folder, it should be okay to just do pnpm, and we're going to then give pnpm the command tests, or we could do it, let's call it run test, and we're going to let it print out to the command prompt. so we can see what's going on. So it's going to inherit our command prompt. And then p.on close. So once the tests are completed, we can code. There we go. And we can then just log here the child process. So what we just want to say that the tests that we've been running as the test process is completed. You can just say, well, it's exited with code, and that's the code. We can just write that to the prompt. And then we're just going to exit the top level process. This one that's initialized the server. So that's our test runner, and now we can create our ping router test. So this is going to be our first test to say, do we get ping and the pong return? So many of the tests, typical, like say this is again typical format. You normally have a test folder with the underscores. Again, it could any folder name can do, but this is what you probably typically see if you look on GitHub. And then most tests will have a .test.ts or .test.js format as well, just to highlight that that file contains some unit tests. So what we want to do is import the client from client. So there we go. So it knows, it's just recognized, you know, we've imported it as a package. We're going to use assert, import assert from node assert. So that's going to be doing our checks throughout tests. We're then going to import after, before, describe, and test from node test. So these are the functions that we're going to build our unit tests up with. So the first thing we want to do is describe a set of tests, and that's with our describe command. We're just going to call this ping tests. So it's going to be ping router tests. We're going to have the concurrency set to 1, so you can have multiple tests running in parallel. Again, just for simplicity and for us to see what the log file's looking like, so I can show you what the process is happening. We'll just do it as one process, so it all runs nice and linearly. In that, we're going to define a client and say that we're going to be needing a client to access our server. And whilst it's coupling both our client and our server, so it is kind of where is the error potentially, because the error could exist in our client and how we're calling it, or it could exist in our server. So it does couple it a little bit, but it's quite nice that, like, again, that, you know, once this test complete, that both the client and server are working together nicely. So it's there's pros and cons for having it, you know, the tests running both packages, but because it's a mono repo and all the code's here that we can access and change and modify, again, it's quite nice to have it all in the framework, and it makes the test really simple to write. Because before, we're going to instantiate a new client. So because we've defined the client in our top level, now we're going to actually instantiate it. So before is the command to say, before any of these tests run, do these actions. And we're going to say, tell the client that its endpoint is going to be http /local host 3000, because that's where our server defaults to when it boots up. And then we're going to do test, and we're going to click get API/ping. So just so I know where we're calling on our endpoints, again, for helping us to debug and find out where we're hitting, we're going to call an async function, and this is where the test actually performs. So what we're going to do is before do client.ping and retrieve the response. So the response is that, like, a big object with lots of different parameters in it, what we're interested in, and this is kind of called destructuring. So we're interested in the status that comes from it, which is going to be like the 200, 400, 500 number, and the content. And we're going to now await client dot ping. So we're going to use the client to ping our server, get the results back. And we're going to assert dot strict. Oh, it's changed my assert up there. It's the wrong one. That's the one we want. Strict equal. And we're going to say, first of all, status 200. And we're going to set and strict equal that the content is going to be content.data is going to be pong. Okay, so we're expecting content to have a data attribute, and it's going to be a pong. Let's just do for us so we can see what's going on. You can then status and check what the content is, and then after running all our tests, we're going to call a function process.exit. So we're going to just exit the tests. There we go. And as you can see, actually it's cleaned up our imports a little bit. So that is our first unit test, just to see whether ping returns pong. Now we're going to just define a couple of functions in our package.json, so we can then run pmpm, run these commands to get our test suite back. So we're going to have test, and this is going to be our tsx underscore tests underscore test runner. So this is going to actually be running our top level. Yes, and then we have that other one called run tests command, and this is going to be that actual running of the tests within that process. So we're going to run node. We're going to have to import tsx for this one, because we want node to run the tests, but also we want it to not have to compile the TypeScript to JavaScript. So we tell node to use tsx to run it, but then run it in test format. So tests, and then we can do star.test.ts. So what it's going to do is going to be, this is a wildcard there, the star, to say anything in the test folder with the star tests. And then what we can also do at the top level, so we don't actually always have to use the filter command. We can do pmpm test server, and in here we'll do pmpm -f as test. So that now should do tests framework from the top level. So that test will then call, this test server will run this file, and then this one will run the process run tests. Fingers crossed. Let's see how it goes. So pmpm test end. Oh, sorry. Call it back end. Sorry, that's my reference. I call it. This is test server. It's running the server, and there we go. Oh, but we failed. That's okay. That's no problem. So we have managed to run the tests, which is fantastic. So what we've done here, you can see the client has fetched ping, so that's come from our client. If we remember, go back to our client code index. It is run here, so it's called our fetch program, our fetch function. Response time, that's come from the server. If we remember back to our middleware, so the log there, so it's logged that. It's then got to our default local context, and it's got to then authenticate, and then it's got to 200 and return undefined. So it's returned successful, but it's not defined our content. So we need to have a look at why that may be the case. So if I go back to our routers ping, so first of all here we do not have back into log, so we just let's first add that so we can see where we've gone awry. And see, let's do that, run that test again. So it's booting up our server, running the tests, and it has got to ping, so that's all good. So it feels like there's something going on with us unpacking that content in the client. So let's double check here. So probably the best place, let's say, put debug first. Let's try and do a console log here. Let's see if we can get. Let's just see if we can log the response. So this might be quite a heavy output. So make sure it gets. There we go. So yes, so we've got the object here, which is all well good. So yep, content is undefined there. So it might be then, as we progress here, something to do with this data here. So let's first of all, let's check what the content type it's returning. So we've successfully got to that stage. We can run this again. Aha! So the content type, there's the error there. Content type, I've misspelled rather than that. It should be a dash. So hopefully that was work our way through. There we go, fantastic. So what we've got there is got to the ping as we've printed out that content type application.json. So it was my error there on just typing a string. Shows how easy it's done. But now it's returned, and what we've done is response, and the response is error is null with data pong, which is exactly what we expect it to be. It is now ticked to say it was a successful test. We can now delete that console log, and if we go back to our ping.tests, ping router test, we can also remove that console log as well, just of interest. And as you can see, there's strict equal there. I expect content, I expect it to be data, and expect pong to be within that. And that's exactly what we have there. So that is us creating our client that is now connecting to our server and calling the ping request. And also we've just demoed how you can use the tests to do a bit of debugging to find out where that error may be. So now we've, that's pretty much the end of this this episode. Like I say, next one we will now go and review our middlewares, and actually I'll use this test as a way of showing, I kind of got a little bit of a hint here of how the different middlewares operate and in what order. So we'll go back through that in a bit more detail about how they operate and in which order, and like you say, then show that approach a bit more detail. Following that, we will then build out our user endpoints for the client, and with that all done, we will then get on to the start of the web app, because then we've got a client that can actually access our data. So let's create the web app where we can have users logging in and then accessing whatever application that we're deciding to develop. Of course, in this case, it's a nice, simple to-do app. So yeah, thank you very much for watching, and hope to see you in the next episode. Bye bye.